Hi guys, today we're going to be dividing polynomials. So before we get started, just make sure you know your exponent rules. This is going to be really helpful in this section. And if you don't, make sure you go ahead and pause and go back and review those. But today we're going to hopefully be able to divide polynomials in two different ways. And then at the end, I'm hoping that you will be able to understand the relationship between a polynomial and its solution if there is a remainder of 0. So we're going to go ahead and start off with a basic example of dividing a polynomial by just one monomial. So in this case, I'm asking you to divide this entire polynomial here by this one term 4c df. So instead of sitting here and trying to figure out how to divide this all as one, what I would encourage you to do first is rewrite it as 3 separate individual problems. It's going to make it smaller and easier to handle. So what I'm going to do is take everything here and divide it. So I'm going to take 20c4d squared f minus 16c df squared plus 4c df, and all of that's going to be divided by 4c df. And notice I wrote it as a fraction because that's going to be more familiar to us rather than the long way of writing it. So then what I can do is individually break these up and divide each small part, and that will help me get my final answer. So I'm going to work with the first part originally. So that's going to be 20c4d squared f all divided by 4c df. Then I'm going to do the same thing for the middle. So I'm going to have minus 16cdf squared divided by 4cdf. And then lastly, I'm going to have plus 4cdf divided by 4cdf. So now we're just going to divide each fraction individually, and this is where your exponent rules are going to come in handy. So in the first one, when I reduce, I take 20 divided by 4. That's going to get us 5. And then we have c to the 4th over c. So remember that I'm dividing, so my exponents I subtract. So I'm going to get 4 minus 1, that's c to the 3rd. Then same thing, 2 minus 1 for the d gets you d to the 1st. And then for the f's, f1 over 1 is 0, so those cancel out. So I have no f's in this first fraction. Then I'm going to move on to the second one. So negative 16 divided by 4 is negative 4. My c's will cancel, the d's will cancel, and then I have f squared over f to the 1st, which will just leave us with an f to the 1st. And then the very last one, I have 4cdf plus 4cdf. Well, everything cancels, all the c's, d's, and f's, and 4 divided by 4 is 1, so I get a plus 1. So here is my final answer divided out. Notice it's a lot simpler than it looked. There was a lot of variables, a lot of numbers, but if you break them up into individual fractions, it makes it a lot easier to reduce. All right, so that's when you divide by a monomial, or one term. Okay, now we're going to start talking about long division, where we have a division, or a divisor that's got addition or subtraction in it. So here we have x squared plus 7x minus 30, and I want you to divide that by x minus 3. So when we first learned long division way back in elementary school, you learned it as maybe 50 divided by 3. So 3 goes into 5 once, so 1 times 3 is 3, and we subtracted, and you get 2. You bring down the 0, and then 3 goes into 26 times with a remainder of 2, so we would write that as 16 and 2/3. So this is how you learn to divide way back when you first learned about division. So the same concept is what we're going to use here. We're just now going to have variables in it. We're going to have x's. So I'm going to go ahead and set this up just like I would in long division. So I'm going to have x squared plus 7x minus 30 all divided by x minus 3. So now what you have to do is you have to think about taking this divisor into each of these terms individually. So what I'm going to do is take x times something that's going to get me x squared. Well, x times what gets us x squared? That's an x. Okay. So what I'm going to do now is I'm going to take x times x, that gets us x squared, and then x times negative 3, that gets us negative 3x. Notice that when I distribute this, I should have the first terms matching. I have an x squared and I have an x squared. If they don't match, that means you're multiplying by the wrong thing on the top. So now I'm going to go ahead and subtract. So when I subtract those, x squared minus x squared cancels. 7x minus negative 3x becomes a positive 10x. And then I can bring my last term down. Also notice that I lined my variable up with the x column. So this was just an x to the 1st, so I lined it up here. And then I can continue on. So now, same thing. I'm going to take something times x to get me 10x. Well, what's that? That's a positive 10. And then I can FOIL real quick. 10 times x is 10x, and 10 times negative 3 is negative 30. So that worked, and now I can go ahead and I can subtract again. And when I subtract, my x's cancel and my 30s cancel, and I'm left with a remainder of 0. So what this means is that my final answer is x plus 10. Now, notice I had a remainder of 0. What I put up at the top here was that when a remainder is 0, what that means is that that answer is a factor of the polynomial. So in other words, what I could say is the x plus 10 times the x minus 3 that I divided by would get me my original equation. So that is a factor of the original polynomial. So remainders of zeros means they're factors. That's important. Make sure you write that down. Now, sometimes when you are dividing polynomials, you're not going to get a remainder that's 0. Maybe it doesn't work as nicely. So I'm going to go ahead and go through an example of that, and then we're going to go into our second method of division. So here's my problem, a squared minus 3a plus 11 divided by a plus 2. So remember, we're going to go ahead and write it in our long division format. So we have the divisor on the outside. So like we started before, I want a times a value to get me a squared. Well, a times a is a squared, and 2 times a is positive 2a. Remember, we're always subtracting, so when I subtract, I'm going to have my a squareds cancel, and negative 3a minus 2a is negative 5a. And then I can go ahead and bring down my last term, so bring down the 11. So now when I multiply, a times what gets us negative 5a? Well, that's a negative 5. So negative 5 times a is negative 5a, and negative 5 times 2 is negative 10. So I've got that part now, and at the end there's nothing else to bring down. So now I have to deal with my subtraction. So remember, when we subtract, 2 negatives become a positive, so these will cancel, and 11 minus a negative 10, that is the same as adding 10, so we get 21. So notice this isn't a 0, that's a remainder. So what we do with a remainder is we write it in its fraction form. So we're going to take this up to the top, okay, and we're going to write it as plus, because it's a positive, 21 over whatever equation we divided by, so a plus 2. So now my final answer would be a minus 5 plus 21 over a plus 2. So anytime you have a remainder, you need to write it at the end in fraction form. All right, and that's our answer. So the process is the same as a remainder of 0. It's just the very end, what you do with the remainder is what changes. Obviously, if it's a 0, you don't put anything at the end. Okay, so that's it for the long division. If you need some extra examples of long division, please feel free to write yourself a note to ask in class, and I'll go through a couple with you.